All right, guys, Mr. Antonucci here. In this fourth part, we're going to do the washer method again, but this time if we rotate it around a vertical axis like the y-axis, the thing's going to work exactly the same, except you have to do everything in terms of y. Okay, I'm going to show some of this, the setup here, and some things in Desmos as well. So first example here, we want to find the volume of the solid revolution generated by revolving the region bounded by y equals 2x and x squared about the y-axis. So the first thing we need to do is find the limits. So 2x equals x squared. So x squared minus 2x equals 0. Factor out an x, and you get x equals 0 and 2. Okay, if we draw this region, y equals 2x looks like this, and the parabola rough draft rough graph looks like that, and then we'll go from 0 to 2. So this region, and we're going to revolve that region about the y-axis. Okay, so if x equals 0 and 2, then y is going to be 0 and 4. Okay, so we have to be careful here because we're revolving it about the y-axis, so our horizontal strip is what we need, and we need to rotate that around, and you can see the washer forming there. Now, instead of the top and bottom boundary, you have a right and left boundary. The big R, the outer radius, is usually to the right, and the little r, the inner radius, is going to be the boundary that's on the left. So if I take y equals 2x, that means x equals y over 2. And if I have y equals x squared, then x equals square root of y. Now, you have to be careful here because it could be plus or minus square root of y, but the region is the positive y values here, so you would have square root of y, positive square root of y. Okay, so the outer radius is formed by the parabola, which is going to be square root of y. And the inner radius is formed by the line, which is y over 2. So the volume is equal to pi times the integral from 0 to 4, not 0 to 2. Be careful, we're doing this in terms of y, so the limits have to be in terms of y. Square root of y squared minus y over 2 squared dy. Okay, so this is going to be pi integral 0 to 4 of y minus y squared over 4 dy. So you'd have pi times y squared over 2 minus y cubed over 12 from 0 to 4. If you plug in 4, you would get, if you plug in 4 and 0 and subtract, you're going to end up getting 8 over 3 pi. And that's the exact answer. If you need the decimal, you can pump it into Desmos and get the decimal value. All right, let's look at another example. All right, so in this example, we're going to do the graphs of f of x equals x squared, g of x equals negative x minus 2 quantity squared plus 4. And we're going to do the region about the y-axis. I'll show you how to do this on Desmos, and again, what to write in order to show sufficient work. Okay, so we have our region graphed here in Desmos, graph the two functions. What I'm going to do is click and get the intersection points right here. And so if you have x squared equals negative x minus 2 squared plus 4, you would have x equals 0 and x equals 2. So, but we're going to need the y values. So when x is 0, y is also 0. Forgot to put my y on there. And when x is 2, y equals 4 in either case. Now, we're going to have to get so we have the limits of integration. If we have a representative slice, let's just sketch it over here. You have this parabola, and then we have this parabola, and you have a horizontal line slice, and you're getting that rotated. Okay, so the outer radius is given by the lower parabola, which is x squared, and the downward opening parabola, the blue graph, is going to be the top or the left boundary. So big R is going to be f of x, and little r is going to be g of x. But we can't do it like this because we have to get everything in terms of x instead of y. So we have y equals x squared, then x is going to be square root of y, and that's going to be our big R. Okay, so the other function, y equals negative x minus 2 squared plus 4, that implies that x is going to be negative square root of negative x y minus 4 plus 2. Okay, and that's going to be our little r. So what I'm going to do is over here, we're going to do pi times the integral from, what do we say, 0 to 4 of big R, which is square root y squared, minus little r squared, which is negative square root of negative y minus 4 plus 2, close those parentheses, square it, and then dy. Now the problem is we don't have parentheses here, and then we're going to need it to close the integral here. So it's 16.75516, blah, 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 blah. So on the exam, you would have to write v equals pi times the integral from 0 to 2 of square root y squared minus negative square root negative y minus 4 plus 2 squared dy, and then that's going to be approximately 16.755. Okay? All right, guys, that's with respect to the y-axis. Hope that was helpful to you. Reach out if you have questions. Take care.